You can see we want to calculate in part A, we want to calculate the net force first, and then use the net force to calculate the net work. Part B, we want to calculate the work done by each individual force, and then use them to calculate the net work. Okay, for both part A and part B, before we can do the calculation, we always need to do the force analysis. So you have some force F equals to 50 Newton to pull the object, the crate, and the motion, of course, is along positive direction, where V equals to 5 meters, okay, the distance. This is positive direction. And this is positive Y direction. And we have other forces, right? Let's see. Okay, we have some weight here. W equals to mg. Do we have mass there? 10. Okay, so this is 10 multiplied by 10 equals to 100 Newton. And then we also have some normal force here. And we also have some frictional force here. And for the frictional force, we directly give you the magnitude. How much is that? 25. So you don't have to calculate it with mu kn. Okay, it's 25 Newton. And normal force here is unknown, but we should know how to calculate the normal force. Remember, right? We have done a lot of problems. If you write down the Newton's second law along y direction, you should be able to calculate the normal force. Okay, now let's try to calculate the net force. Okay, what's the best way to calculate net force? Okay, the best way to calculate the net force is you decompose F to get Fx and Fy, right? Okay, so Fx equals to F multiplied by cosine theta. If you put a number, you will see that it equals to 50 multiplied by cosine 36.9 and 40 Newton, right? Fy, then if you do the calculation, you can show that it will be 30 Newton. Okay, so this equals to 40, this equals to 30 Newton. Okay. Now, if we try to calculate the net force, we have to use the vector addition, right? So the vector addition, if you do the vector addition, remember how do we do that? The next step is that you have these forces, you write down all the x and y components, right? So you are going to get, if you write down all the x components together, you see that it should be fx minus f. This will give you f net x reaction, right? Any question here? And f net y should be n plus fy minus w, right? Okay. Any question here? Here I skip the few steps. If you are not comfortable with that, you just write down fx, fy, nx, ny, w, x, wy. This small x, small fx, small f, fy. Okay, put them together. You can see that's how you combine them. Okay. So here, when I do this, I just look at this graph. Here you have fx, here you have f. So fx subtract small f, and here you have n. You have fy. So n plus fy minus w. Now, we know that to calculate the net force, we have to calculate this, first calculate this, and then combine them with Pythagorean theorem, right? And here, let's look at, can we calculate this? What's the number? It should be 4k minus 25 equals to 15 Newton, okay, right? So it's easy. And for this one, if you try to calculate this directly, you are going to have trouble here. You don't know n, right? We don't know the normal force n. Okay, but here, in fact, you don't even need to do any calculation. You should be able to tell the result directly. What's the result? The calculation of this. What's the result here? 0. Okay, how do you know that? Okay, please note that f net y is related to the acceleration along this direction, right? F net y equals to m a y. But what is a y? 0. So of course this equals to 0. In fact, if you want to calculate normal force, we have to use that back and go back to calculate normal force. But here you can get here, the answer is 0. Any question here?
Can you repeat that again? Y equals 0.
Okay. Physically, it says that along this direction, you don't have motion.
Right.
So acceleration has to be 0.
Right.
Acceleration is 0, that means the net force along that direction equals to 0, right? So F net y equals to 0. You don't even need to write on this, in fact. Okay. Question? Fy equals to 30, but F net y equals to 0. Because F net y is n plus Fy minus w. They are two different things. Okay? Fy is the y component of this pulling force. And F net y is the y component of the net force. Okay? So pay attention to this subscript. I put this subscript because it's useful. Okay? You cannot just look at the main letter here, because most of the force we are going to call it F. Any question here? Now, then the net force is simply, okay, now we can calculate net force and then calculate the work. Net force will be square root of F net x squared plus F net y squared, right? So equals to 15 squared plus 0 squared equals to 15 Newton. So that is the net force. And in which direction the net force? Positive x, right? Because it has only positive x component. It doesn't have y component. So it's along x direction. It's positive, x component is positive here, so it's along positive direction. Now, if we want to calculate work, then W net equals to, let's start the definition here. So it should be the net force multiplied by distance multiplied by 4 sine theta. Okay? So net force equals to 15. Distance is given 5 meters, right? Multiplied by 4 sine. What is the angle theta here? Is it 36.9 degree? twice about that. Is it 36.9 degrees? No. Please note that theta, when you calculate the work for a particular force, then the angle theta should be the angle for that particular force. Okay? If you calculate, hold on 1 minute. If you calculate the work done by the net force, you need to find out the theta for the net force. 36.9 is the angle for this external pulling force. But we are not calculating the work done by this force. So please pay attention to that. When we talk about work, you need be clear which force you are talking about. So here, what is the angle for the net force? 0 degree, right? Okay? It's not 180 because it's in the positive direction.
How is it 0?
Okay, let's look at. The angle by definition is the angle between the direction of the motion and the direction of the force. What is the direction of the motion?
Positive X.
To the positive x direction. What is the direction of the net force? To the positive x direction, right? So of course the angle between the two, 0. They are in the same direction. Okay? Think about which force you are talking about. Think about the definition of the angle. So you can see here is the point that net force is along the direction of the motion, so the angle is 0. This force makes some angle like 36.9 degrees with it. So if you want to calculate the work done by that force, you want to use that angle. Okay? So here, most important thing, again, I think the best way to do is even for the theta, put the subscript here. So you know you are talking about the angle for which force. Question?
Can you use the tangent inverse to find the direction?
If you want to use the tangent inverse, okay, find direction, okay, see, you have to do it here. Here I directly say it's 0 because from this analysis, you know, if you want to use the rigorous mathematical analysis, then you have theta net equals to inverse tangent of f net y over f net x. You can see that this is 0 over 15. So inverse tangent function of 0 is equal to 0 degree. Again, it should say 0 degree, right? Any question here? Okay, so if you are a mathematician, you probably want to do that because we are physicists, so we can look at the graph to know it has to be 0 because they're in the same direction. And then this will, what do you get for this one calculation? 35, right? Cosine 0 degree equals to 1. So it's 75. Any question here?
75 what?
Newton
75 what?
Joule.
Joule, okay. Anytime, if you already use standard unit, you just need to look at it. We are calculating work. So it has to be joule. And by the way, what's the, how to pronounce this precisely? Joule? Anyway, it's German, so it may not be what we think. Oh no, it's not German. It is British. He is a British. This is from one of the scientists. Okay, now this is for part A. Part B, we are going to calculate the work in a different way. Okay, of course, finally we should get 75. But now let's look at this way. In fact, I like it better. Okay, I also would expect you like it better. This is if you have some problem in the test like that, I suggest you to use this way. Okay. But of course, it starts like that. You have four forces here, right? W equals to mg equals to 100 Newton, F equals to 50 Newton. The angle of F is 36.9 degrees. You have N, we don't know what's that. Frictional force is 25 Newton. Okay. So that means you have four forces. So we have to calculate W, the four works. Let's label them as W capital F. That means the work done by this force F. Okay. And then we can calculate Wn. That means the work done by the normal force N. We need to calculate W. Let's call it Wg. It means work done by the weight or the gravitational force. And then we have W small f. That's the work done by the frictional force. Okay? It seems that we have calculated a lot of quantities, but in fact it's quite easy. Okay? Now, Wf is the work done by the external force F. So by definition, is this force multiplied by the distance multiplied by cosine theta f. This force is given 50 Newton, and the distance is given 5. And what is the angle for this one?
36.
Now you can put 36.9 degrees because we are calculating the work done by this force. And then in this case, because this is the direction of the motion. Okay. This angle, 36.9 degrees, is the angle between this force and the direction of the motion. Okay? Now, what's the number here? 50 times 5 times is 200. Sure. Okay? Now, let's look at Wn. By definition, it should be normal force N times P times cosine theta N. Okay? We know what is the angle theta N here? 90 degrees, right? It's perpendicular to the direction of the motion. We know D, but do we know normal force N? Then how can we calculate it? It has to be 0, right? Because cosine 90 degrees always is 0. So that's why you don't even have to write this down. You should be able to know it's 0. Because the force is perpendicular to the motion, so it's 0. Similarly, you need to really calculate this. What's that? 0, right? Okay, that force is perpendicular to the direction of motion. And then for the frictional force should be small f multiplied by t multiplied by cosine theta small f. Okay, so it will be 25 multiplied by 5 multiplied by cosine. What is the angle for this force? 0? 180. And cosine 180 will give you -1, right? So you get -125.
And why is WG 0?
Okay? If you really want to write it down, it will be mg multiplied by d multiplied by cosine theta g. But this is 90 degrees, so cosine 90 equals to 0. Okay? equals to 0. In fact, you can always check that, okay, so graph help us a lot. If you are business, you are going to look at, okay, this is the direction of the motion. This force is perpendicular to the direction of motion, so the work is there. Okay. And then the net force, the work done by the net force is simply you put all these things together, right? It should be WF plus WN plus WG plus W small f equals to 200 plus 0 minus 125. So 75, the same answer. So you agree with that? I think this is a better way to do it. It's more conceptually straightforward what you are doing here. And the only thing you need to pay attention to is that work is defined for each force. So when you calculate for a particular one force, you need to pay attention to that. You have to use its own angle. Okay, you cannot use some angle from somewhere else.